Hello everyone and welcome back. My name is Mr. Kowalt, and in this video I want to go over the different versions of the ideal gas law equation. So let's get into this. Okay, so first thing I want to do is add the word equation here since we're talking about the ideal gas law equation. There you go. And so first I want to start off with the traditional form that we have it in, PV equals nRT piv nert. So you want to use this equation. And so before I continue, I want to remind you that the only time you're going to use this when you're dealing with gas problems is if there is no change going on in the properties. So in this case, in this sort of problem, they've just given you a set of conditions of a gas and they want you to find the missing condition. So maybe they give you the pressure, volume, and temperature of the gas, and they want to know how much gas is there. Or they give you the amount of the gas and they give you the volume and the pressure, and they want to know the temperature. So in that sort of problem, you're going to use the ideal gas law equation. So if the ideal gas law is given to you in pressure, they give you the pressure, they give you the volume, they give you the temperature, and so on, then you can use this form. However, if they don't give you the number of moles, right? If you're missing moles and they're not asking for moles, maybe they give you the mass in grams, or maybe they give you the molar mass, or they give you the identity of the gas and you're able to calculate the molar mass. So there's a form that you can use in that situation. So first I want to point out, we have to remember that molar mass, and here I'm going to use this kind of italicized M, this weird looking capital M. So this is the molar mass, and molar mass is equal to the mass in grams divided by the number of moles. It's mass per mole, right? Mass in grams per mole. So if I rewrite this as G for grams over N for moles, that's going to be equal to the molar mass, this M here. So molar mass is equal to grams G over moles N. So here I have, if we rearrange that, then the number of moles is going to be equal to grams over the molar mass. Well, I have N in this equation, so I can replace M or N, or I can substitute this in for N, and I get this form of the equation. So if you're ever given a problem where they give you the mass of the gas and they don't give you moles or anything else, and they want you to solve the problem finding some other property, then this is the one you want to use, right? So let's say they give me a 5 grams of oxygen gas, and they gave me the temperature and they gave me the volume, and I need to find the pressure, right? But I don't know the moles. So I'm given the volume and the temperature, but I'm supposed to find pressure, but they didn't give me the moles, right? Well, if they gave you the grams and they gave you the molar mass, you could solve for moles. You could find the moles and then stick that in, or you could just use this form, put in the grams that they gave you, calculate the molar mass of the gas. In this case, it would be O2 gas. So you find the molar mass of O2, plug that in, plug in R, plug in the temperature, plug in the volume, solve for pressure. Done. Okay, so this is a useful form of the ideal gas law constant, ideal gas law equation for problems like that. Well, what if you're asked to find density, right? Or maybe you're given the density of the gas. So in this case, you got to remember that if you have this form and they're asking you to find density, remember density is mass per volume, right? So if they give you the mass of the gas and they give you the volume of the gas, and you can just do gas over volume, or if they give you the density, just remember that density is mass over volume. In this case, G. So G, if we rearrange the equation here to be G over V, that's equal to the density. then that's going to be equal to the molar mass multiplied by the pressure divided by R divided by temperature. So this is a good form of the equation to use if you're trying to find density, or if they give you density, you can use this. Now you can rearrange this into this form, and the reason you might want to rearrange it in this form is an easy way to remember. It's got a good mnemonic device, and that is the molar mass kitty puts dirt over its pee. That's right. That's a good way to remember. So molar mass kitty remembers to put dirt, DRT, over P. It's P, right? So molar mass equals DRT over P. So this is a form to help you remember. That mnemonic device helps you remember this form, which is basically the same as this one, just rearranged. So remember, density is equal to mass over volume. And if you rearrange it, you get molar mass is equal to the density times R times temperature over pressure. Okay, so remember, I'm going to say it again. Molar mass kitty remembers to put dirt over its pee. So molar mass is equal to DRT over P. So those are a few of the different versions of the ideal gas law equation that you can use to help you solve problems. I hope this is helpful and entertaining. I hope you enjoyed the video. If you did, then please like the video, share the video, hit that like button. Also, make sure that you subscribe to the channel, hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a problem or a question you need help with, put that down below. I would love to do that for you. Thanks for joining me. Have a great day.